Hello everybody and welcome to the last two videos of Unit 2. In this video we're going to talk about molarity. And first let's discuss what molarity is. Molarity is the number of moles of solute dissolved in 1 liter of solution. So here is your formula. Capital M notes molarity. So whenever we talk about a molar solution, we're going to use capital M equals moles divided by liters. So a 6 molar solution is one that has 6 moles of solute dissolved in 1 liter of solution. I have attached here to our video a little way of helping you remember what molarity is. So take a look.
Molarity is moles per liter of solution. Take the grams, convert to moles, then divide by liters of solution. Molarity is moles per liter of solution. You take the grams, convert to moles, then divide by liters of solution.
I hope you liked that little clip, and I'm pretty sure the song will be stuck in your head and you'll be singing it in your sleep. So let's talk about how a chemist will prepare solutions based on molarity. First, you need to ask, can you weigh moles on a balance? No, you can't, but you can weigh grams. If we know the grams of solute, we can use a conversion factor. And that conversion factor is that 1 mole of something will equal the molar mass of it, and we can convert it to moles of solute. If you are given the moles of solute, and you need to figure out the mass in order to weigh it out, you can use that same conversion factor, just the reciprocal, and figure out the mass of the solute needed to make that solution. When we use these conversion factors in stoichiometry, we can determine the number of grams needed. Then you add the grams of solute to a volumetric flask and add the water to the 1 liter line. I will, in class, show you a volumetric flask and let you all see exactly what that looks like. They're calibrated to a very specific volume, and they're very expensive because they are so precise in their measurement. Just to refresh your memory, the solvent is what's doing the dissolving, and the solute is what is being dissolved. Typically, our solvent will be water. And again, here's our formula. Capital M notes molarity, and it'll be moles divided by liters. Let's take a look at a typical and useful example of molarity. Question here is, what is the molarity of a solution that contains 125 grams of ethanol, ethanol C2H5OH, and a 0.25 liters of solution? This is where I want you to begin using the problem-solving method, and this is the method that I'm going to require you to use before you come up and ask me a question. So make sure that you follow along with this. When we read a problem, any word problems, and there's a lot in chemistry, read it and reread it and read it again. Read it out loud if you need to, so you really comprehend what you are seeing and what the problem is asking. Once you think you have a really good hold of what the problem is looking for, then you need to write 2 things down. First of all, I want you to write down the givens. What does the problem tell you? In this problem, we know we have 125 grams of ethanol, and we have 0.250 liters of solution. That's given to us. Second thing I want you to write down is, what are we being asked to find, or what are we solving for? And in this problem, we're being asked to solve for molarity. If you are able to, at this point, write down the formulas you're going to need. Well, we know molarity is going to be moles of solute over liters of solution. If you've written down your given, your find, and formulas, if you could write down the formulas, then you can cover up your problem and just focus on the numbers and the math. You don't need to go back and look and get confused by the words. Now that may seem like a simple problem right there, but our word problems are going to get very, very involved. So if you're able to do this, you're going to be able to keep a lot of confusion out of your mind. Now it's just a simple plug and chug. First, we need to go through and convert our grams of ethanol to moles of ethanol. We use that by finding ethanol's molar mass, and you know the molar mass will equal 1 mole. Doing the math, we get 2.71 moles of ethanol. Then we can plug the moles and the liters into our equation, our formula. We're going to take the 2.71 mole and divide it by 0.250 liters. And that'll tell us that we have 10.9 molar solution. Make sure when you're following sig figs that you don't use conversion factors. You'll look back at the original value, and 125 has 3 sig figs. You'll want to carry that through. Here's another example. How many grams of sulfuric acid are in 0.8 liters of 0.05 molar sulfuric acid? Let's write down our givens. Well, we're given the molarity of the sulfuric acid as 0.05, and we know we have 0.8 liters of it. We're being asked to find grams of sulfuric acid, and we know we're going to use our molarity formula. Now that we have these written down, cover it up. Let's go through and solve the math. First thing, use your molarity formula to figure out how many moles of sulfuric acid you have. So you're going to take your 0.8 liters, use your molarity, which is 0.05 moles per 1 liter. That's what the big M stands for, moles per 1 liter, equals, and then this is our moles of sulfuric acid. Once we know the moles of sulfuric acid, we can go through using the molar mass of sulfuric acid and calculate the number of grams. Remember to watch your sig figs. Sometimes you want to dilute a more concentrated solution that is already made, and we do this by adding more solvent. So we usually add more water. But when we add more water, we're not changing the number of moles of solute because we're not adding more solute. We're not adding more salt. We're not adding more of the solid to dissolve. We're adding more water. So since the solute controls the number of moles in molarity or in our concentration, it's not going to change. And since the number of moles will remain constant, we can use the dilution formula, M1V1 equals M2V2, to figure out a new concentration or to figure out a volume of solvent that we're going to need to add to get the new concentration. So let's take a look. If 200 milliliters of 3.0 molar H2SO4 are diluted to 300 milliliters with water, what is the molarity of the resulting solution? Well, here's our givens. We know V1, we start out with 200. We know our original concentration as 3.0 molar, and our new volume that we want to dilute it to is 300. So based on that, what is our new molarity? Well, we can use our dilution formula, plug in our numbers, and solve for M2, which will be 2 molar. M1V1 equals M2V2 is going to be very important in solving dilutions. Here's another one. What volume of 0.5 molar sulfuric acid must be diluted to 100 milliliters to create a solution that is 0.150 molar? Well, here's your given. We know V2 is 100 milliliters. That's our final volume. We know M1, we start out with 0.5 molar, and we know that our M2 is 0.150 molar. We're going to be finding V1. What was our original volume? Using dilution, plug your numbers in, solve for V1, and we must have started with 30 milliliters of the 0.5 molar sulfuric acid in order to make our new solution at the new volume. Not bad. Simple algebra. Something you want to keep in mind when we're doing dilution is to never add water to concentrated acids. So you always want to make sure that you add concentrated acids to water slowly. It gives the acid a time to dissociate in the water. Molarity, capital M, is a useful description of a solution. It will give us the number of moles of solute in 1 liter of solution. It's useful to convert milliliters of solution to moles of solute in equation situations. Molarity of solution can also yield moles per liter of the ions produced when the solute ionizes in water, using the formula of the solute as a conversion factor. Molarity also adds another way to calculate mass or moles from volume. Just like we use density, the number of grams of substance or solution in 1 milliliter or 1 cubic centimeter of solution or substance. So molarity can be used in several different ways to help us solve stoichiometry problems and conversion problems. Now, number 2 in that last slide talks about moles of ions. Here I'm going to just briefly give you a look at how we can use molarity to figure out the concentration or the number of moles of ions in a solution. How many moles of chlorine ions are in 10 milliliters of a 0.240 molar solution of barium chloride? What you would set up is you start with 10 milliliters of solution. We know that in 1,000 milliliters, or 1 liter of that solution, we have 0.240 moles of the barium chloride. We also know that in 1 mole of barium chloride molecules, or compounds, if barium chloride broke up, we would get 2 chlorine ions from every barium chloride compound. Using that information, we take our 10 milliliters, multiply it by the moles of barium chloride, and divide by 1,000, so that our milliliters cancel. Then we're going to take our relationship between the compound of barium chloride and the chloride ion to set up a conversion factor to cancel out moles of barium chloride. And when we do the math, we get 0.005 moles. Remember to keep in mind your sig figs. Our original sig figs was just 1, so we need 1 here. And we'll do plenty of practice of these. So that is the end of the molarity video. The next video we will be quickly talking about solution stoichiometry, and that will be the last video of our unit.
Molarity, molarity is moles per liter of solution. Take the grams, convert to moles, then divide by liters of solution. Molarity, molarity is moles per liter of solution. You take the grams, convert to moles, then divide by liters of solution.